Hi everyone, my name is Michael and today we're going to be talking about math. But I'm not going to be teaching you math. We're going to go deeper than that. But first, let's take a step back. Anyone who's ever been to college has definitely been asked, what's your major? And whenever I tell people I'm a math major, I always get a response like, ooh, you're very smart. And first of all, just because you're good at math does not mean you're smart. And second of all, it made me think, how come some people are good at math and some people are not? And ultimately, I want to tell you about what I found to be the causes of variation in math skill. First, we'll be looking at what's involved with math skill, and then we'll look at a twin study, and then an fMRI study, and finally a study on preschoolers. But let's first talk about what goes into math skill. Now, I've broken it down into essentially two pieces. There's memory, and then there's logic. Now, memory has to do with memorizing patterns, rules, formulas, and logic has to do with recognition, like recognizing patterns and recognizing where to apply certain knowledge. But it also has to do with abstract ideas and using your reasoning skills. But what I want you to keep in mind moving forward is that if a study is talking about memorization or arithmetic, then that has to do with memory, obviously. But if they're talking about like puzzles or riddles, then that will have to do with more logic. So now that we got that all out of the way, let's talk about twin studies. So the purpose of a twin study is that it measures heritability, which is one way to observe genetic influence. Now, one thing to keep in mind about heritability is that it describes a population, not an individual. So a heritability of 0.5, for example, means that about half of the variation that we see in a trait, such as math proficiency, has to do with genetic individual differences, not necessarily that half of someone's math skills come from their genes. So the way heritability is measured is by comparing identical twins to fraternal twins. Now this is because identical twins share 100% of their genes, while fraternal twins share just 50% of their genes on average. Now, assuming that any pair of twins share the same environment, then any variation that we see in a trait has to come from genetic variation. So if identical twins are much more similar for a trait than fraternal twins, then that tells us that genes play a large role in the variation of that trait. But now let's actually jump into the study. Conducted by Professor Claire Hughes of the University of Cambridge, England, part of her study looked at math test results of 10-year-old twins in the United Kingdom. Now in total, there are about 800 pairs of identical twins and about 1,400 pairs of fraternal twins. The identical twins yielded a correlation of 0.68, while the fraternal twins yielded a correlation of 0.44. Now the resulting heritability then was 0.48. Now this 0.48, this tells us that about half of the variation we see in math skill come from genetics, while the other half come from environmental factors. And these environmental factors can be social factors like family and friends, cultural factors like attitude and religion, and even other health factors such as diet, sleep, stress levels. But now that we've identified genes and environment as both equating to half of the variation that we see in math skill, let's look at how genetics affect math skill. Now to see the role of genes in action, I want to look at an fMRI study. Now this is because fMRI studies display neural activity in the brain. They tell us what's actually going on inside of a person's head. Now what we want to see are any differences in brain activity among individuals of varying math skillage. A group of researchers conducted a study on 51 students of Linköping University, Sweden. Participants were tested on their math-related cognitive function, which included a timed arithmetic test and a working memory test. The timed arithmetic test included 2 minutes to solve a series of equations, which increased in difficulty. The working memory test included repeating digits in order, repeating digits in reverse order, and repeating digits in order from least to greatest. Now, after testing, resting state fMRI data was collected from each of the participants. This is in order to see if math skills can be predicted from certain neural pathways. One specific pathway that stood out was one that connected the left angular gyrus to the left inferior frontal gyrus. The strength of this connection had a positive correlation to math skill. The stronger this connection, the more proficient the participant was at math, and vice versa. Now, because math proficiency can be predicted by the strength of certain neural pathways, it can be concluded that a certain extent of the variation in math skill from genetics results from genetic variation in connectivity strength. But remember that earlier we established that genetic variance was only half the puzzle. So to see how environmental factors affect the variation of math skill, let's look at a preschool study. So the reason I want to look at a preschool study is because it's recognized that early math skills are a predictor of later mathematical proficiency. And what we want to see from this study is what activities or behaviors are associated with math proficiency. Now, psychology professors Kelly Edens and Ellen Potter of the University of South Carolina, United States, conducted a study involving 14 four-year-old preschoolers. Now, these children's math abilities were tested and scored based on counting skills and spatial skills. Counting skills involved naming the orders of numbers and counting objects. Spatial skills, which was considered more cognitively challenging, included naming shapes, matching shapes and matching sides of shapes, and replicating building block structures. When observing the activity choices of each child, it was found that the level of cognitive exertion of each activity was directly correlated to that child's level of math skills. Now, the activities were put into two categories: low yield and high yield. Low yield activities included playing with sand and playing with water, while high yield activities included art, building blocks, and puzzles. The study concluded that incorporating more of these challenging high-yield activities into children's free time and lessons will help develop early math skills. Now, you may be thinking, well, maybe children that are naturally good at math just choose more challenging high-yield activities. But it was found that the way you view your math capabilities is positively correlated to math activities and math skills. So what this means is that environmental feedback can lead to an interest in math. More importantly, it means that giving positive and encouraging feedback to children regarding their math capabilities will help lead them to choosing activities that nurture math excellence. So hopefully this study gave you a brief idea to the extent at which environmental factors can affect the variation of math skills. But now let's go over what we learned. We talked about how logic and memory are used in math skill and how these components are often measured when determining math skill. We discussed a twin study which revealed that genetic and environmental variance are equally responsible for the differences we see in math skill. Then we looked at an fMRI study to see how genetics affect math skill, finding that some individuals have certain neural pathways that are naturally stronger. Finally, we looked at a preschool study to get an understanding of how our environment can affect our development of math skills, finding that mentally challenging activities, as well as encouraging feedback, can help increase math proficiency at an early age. But if you're still not satisfied and want to learn more about this, then I encourage you to look this up on your own, because there is so much information out there that I just couldn't fit it all into this video. But if you've made it this far, then thanks for watching and have a great rest of your day.